All right, the last 7 problems on the first page. Here we go. So we have an earthquake. No, we have QR minus Q squared minus RS plus QS. And to factor this, I look for a greatest common monomial, but there's nothing. I have 4 terms. The only way I can really deal with this is by grouping. So I'm going to group them together. I'm going to group this piece together, and I'm going to group this piece together. So these 2 halves. All right, so I have QR minus Q squared. And over here, I have negative RS plus QS. All right, now I have a greatest common monomial of Q. So I can factor out the Q. So I Q times the quantity R minus Q. All right. Now over here, my Q is negative here. I want my Q negative there. And my R is positive, and here my R is negative. So you know what I'm going to do? There's an S for both of them. So I'm going to factor out a negative 1S. That looks a lot like 15. Negative 1S. So over here we get plus negative S, and so we get a positive R, because negative divided negative is positive, minus Q. Oh, check it out. The binomials are the same thing, and now it's the same problem as before. Great. All right, so I can put the Q and the minus S in one parentheses. I can have the R minus the Q in the other. Oh, look at that. And that will get the same thing, my same rainbows and smiley faces. All right, so there's our answer. Cool beans. All right. Yes, I just said cool beans. How pathetic. Now you can really make fun of me. All right, so here we have t squared minus 6tu plus 9u squared minus 4. Now this one's a little bit tricky because inherently I kind of want to break it into 2 binomials. But if I'm looking at this binomial, or this, not binomial, this polynomial, this monstrosity, this piece here looks really, really like it looks like something that needs to be factored. So let's see if I can factor that. All right, so what times what is 9 that adds up to negative 6? Negative 3, right? So we can have t minus 3u times t minus 3u. That's the same thing. So really, we can just say t minus 3u squared minus 4. Oh, minus 4. I have a square term here, and I have a square term there. That's great. That makes this is a difference of squares. And a difference of squares, we're going to have 2 grouping symbols. We have to have a plus and I have to have a minus, just like any other difference of squares. Positive 2 times negative 2 is negative 4. All right, so then that means we have t minus 3u and t minus 3u. And there we go. That's not too bad. Okay, granted it has 2 factorings in it, but that's not too bad. All right. Next problem. This is a magic blue marker. So we have 6v to the, I think it's v to the 3rd. Yes, v to the 3rd plus 3v squared minus 9v. All right, so what goes into all 3 of these? Well, 3v, I mean, that's pretty easy. Greatest common nomial, 3v. So we have 3v, so we have 2v squared plus v, okay, minus 3. All right, so, all right, I can probably still factor this. So I still have my 3v on the outside. So I can't, 2 times 3 is 6, right? I don't want to do 2 times 3. But 3 minus 2 is 1, and that's a 1v, all right. So, all right, so if I have a plus 3 and I have a 2v and v minus 1, because 3 times v is positive 3v, 2v times negative 1 is negative 2v. 3v minus 2v is 1v, all right. This really is a magic blue marker. All right, number 18. So we have 36w to the third minus 9w. All right. So, well, clearly, these are all asking us to factor the problems multiple times. So I'm thinking I'm going to factor this multiple times. And there's a greatest common monomial, 9w, and we get 4w squared minus 1. Oh, yeah, 1 is a square number, isn't it? I have a difference of squares because 4w squared is a perfect square. 1 is a perfect square. So just like any other difference of squares, I'll have a pair of grouping symbols. I'll have a plus and a minus. 1 times 1 is 1, all right? 2w times 2w, and I still have my 9w out here. All right. Finally, my last one before I'm solving, I got x to the fourth minus 1. Well, x to the fourth is a perfect square. So I have x squared plus 1, x squared minus 1. But this is another difference of squares. So this one can be factored again. So we have x plus 1 times x minus 1. But this is not a difference of squares because this is an addition. It's a sum of squares, which isn't really a thing. So I can't do anything else with this. And so there we go. All right, last two on this page. Woohoo! All right, so we have x minus 2 times 2x minus 3 equals 0. So two things have to be true for me to solve a quadratic. It has to be equal to 0, check, and it has to be in factored form, double check. All right, so all I have to do is break it apart and figure out what will make this 0. Sorry, what will make that 0, and I'll find my zeros. Well, plus 2, and so I get x is equal to 0 plus 2 is 2. On this side, plus 3, and I get 2x is equal to 3 divided by 2 divided by 2, and I get x is equal to 3 over 2. And by the way, you can have fractional answers. So those are your two answers, 2 zeros. Great. The last one on this page, we have 2x to the third plus 5x squared is equal to 3x. So the first thing I have to do is I have to make sure it's equal to 0, but it's not equal to 0. So I'm going to subtract 3x from both sides to make it equal to 0. So I have 2x to the third plus 5x squared minus 3x is equal to 0. All right, so I can't help but notice I have an x in all three of these. So I can factor out the greatest common monomial of x. Now, just like, which problem was it? Just like this problem. Remember when we factored out a factor of 3 and we had a 2 and a 3 and we had to get to 1, but we almost got to 5. So here's the thing. 2 times 3 is 6. 6 minus 1 is 5. So I need to multiply this 2 times this 3 to get a positive 6, leaving me with a 1 to subtract out. So we have x times, we have the 2x, and we want the 3, and we want that to be positive, right? Well, 2x times just 1x is going to get me 2x squared, and 3 times negative 1 is going to give me negative 3. And when I multiply this out, I'll notice I get 6x, and that's negative 1x. So that'll give me my positive 5x, and this is still equal to 0. So I'm going to have 3 possible zeros here. So, well, x is equal to 0. That's pretty easy. So we get 2x minus 1 is equal to 0, plus 1, plus 1. So we get 2x is equal to 1 divided by 2 divided by 2. I get x is equal to 0 and 1/2. And, oh, well, it's minus 3, and I get negative 3.